Hello! In this video we'll talk about the encodings of immediates in RISC-V instructions. So recall that load word and store word use constants or immediates that are immediately available in the instruction. For example, these are 12-bit 2's complement numbers. Similarly, add I adds a 12-bit immediate. There is no subtract I because the immediate for add I could simply be negative. If we wanted to do a plus 4, we could add I, S0 gets S0 plus 4. If we want to do b equals a minus 4, we can add I, S1 gets S0 plus negative 12. So the immediates seem to have a really funny order when we looked at them in the instruction, but if we look at them in a different way, they make more sense. Let's take a look at it from the hardware point of view. So a I or S-type instruction takes a 12-bit immediate and then sign extends that immediate into the upper bits. A B-type instruction takes an immediate with a 0 in the least significant bit, IMM 11 through 1, and then sign extends the 12th bit into the upper positions. U-type instruction has zeros in the bottom 12 bits and puts the immediate in the upper 20 bits. A J-type has a 0 in the beginning, then it has 11 bits, and then the remainder of the immediate, and then sign extends into the upper bits. If we look at these, how they're encoded in the instruction, we want to have as much commonality as we can between instructions. And the hard parts of decoding an instruction are finding the important things, the opcode and the function fields and the sources. So the opcode is always in bits 6 through 0 for all of the types. For the other types, the register fields RD, RS1, and RS2 are always in the same place for every instruction. Similarly, funct3 is always in the same place. So the only thing that varies is the immediates. And creating the immediate is one of the easiest things that hardware can do because it's just picking bits. We don't have to access a register file or go out to a memory or use an ALU. So it's pretty fast, so we can afford to put the complexity there. Even so, we try to pack the immediates in as systematically as we can. So for instance, bits 4 through 1 for S and B both appear here. S needs a bit 0, B needs a bit 11, so that's why we pack the 11 here instead of shifting the branch over and putting 11 somewhere else. We get some consistency of the B4 through 1 by putting them here. In the same way, we get some consistency of these bits where possible, and we get some consistency in the location of these bits when possible. So there are only a few bits that are scattered around in different places for different instructions.